Hello, and this video is going to be about finding the probabilities of a binomial random variable. Finding the probability of a binomial random variable using our calculator. Okay, so let's go ahead and set this problem up real quick to make sure it's a binomial. A person is guessing on a 10-question multiple choice test with 4 possible answers for each question. So the thing is, when they go to that first question, is it going to be pass or a fail? It's either going to be get it right or get it wrong. So this is going to be a success or a failure. So that's right. Now, what's the probability of getting this right? What's the probability of getting one right? What's the probability of success? Would be 0.25 because there's 4 possible answers. If you're totally guessing, then that would be your chance of getting it right. 0.75% with chance of getting it wrong. Okay, so if you answer the first one, if you're totally guessing, does this answering this question help you with this question? No, it doesn't. So they're totally independent. And do I have a finite number of questions? Yes. Finite means that it stops. Doesn't go infinite. Okay, so now I'm gonna be like, I'm gonna ask, how do we find these probabilities? Okay, x, let's define x. X is a binomial random variable, and x is the number correct in 10 tries. Okay, so this is a binomial. My two parameters are 10 for the number of trials and 0.25. Okay. Okay, so let's look at this first one. Now the first one we don't need a calculator because this means that if you do 10, this means that they all were wrong. They were all wrong. Okay, so what's the probability they're all wrong? All 10 of them were wrong, so that's 0.75 to the 10th. Okay, we don't need a calculator for this one. This is probability that x equals 10, and that means they're all right. Okay, so you have 10 of those. Now in the last video I said I showed you the formula, which is probability x equals 1, which you should always use the formula. The formula is like considered your work. Okay, but we're never really going to type all that stuff in your formula. We're just going to use a calculator after we show what the formula is. Okay, so what does this 1 mean? This means that you got 1 correct and 9 wrong. So this would be out of 10 questions, you got 1 correct. Now I'm just using the formula. If I got 1 correct, then that means I have 1.25 because one of them were right and the rest of them were wrong. So I have, out of 10 questions, I got 9 wrong, 1 correct. This is a success, that's a failure, and that's how many ways I could arrange that. Okay, so pull in the calculator, and what I'm finding here is I'm finding this one right here. That's what I'm doing. Probably the x equals 1 goes right here. So here's your calculator, and what we want to do to find this, let me scoot it over a little bit and up. What we want to do to find this is we want to go to distribution. Okay, because this is a binomial distribution. This whole thing, all the models are basically just a distribution of the random variables. Okay, so we go second vars. Now we want to go down to our binomial. Okay, so you're going to have some choices here. Okay, so you have 2 choices. And we're going to actually want to pick the PDF. Okay, this is probability distribution function. So these are all PDFs. Each one is a PDF. CDF stands for cumulative. Okay, so pay attention. If you put PDF 4, you're actually finding this. Okay, if you put PDF 3, you're actually finding this, and 2 you're finding this, and so on. 5 this, and so on. Okay, if you put CDF in 5, it's going to add everything up to 5. So if you chose the CDF, it's going to find 1 and add it 0, and add it to 1, and add it to 2, and add it to 3, and add it to 4, and add it to 5. Okay, so that's the difference. Okay, so let me show you how to do this. This would be a binomial PDF, and these are always your parameters. Your parameters are n, comma, p, comma, x. Those are always your parameters. So get a good idea and get used to this. So this is going to be a binomial PDF. How many trials? We have 10 questions. What's the probability of success? That's 0.25. And how many successes do I want? One success. So if we put all that into our calculator, so I'd enter binomial, I do 10, comma, 0.25, comma, 1. Okay, close and enter. Okay. So you have about a 19% chance, I'll say 0.88. So this, and here goes 0.188. Okay, so the same thing with 2. So I'm going to do second entry, we'll pull that right back up. And I'm going to change that 1 to a 2. And I'm still in PDF. See, I'm in PDF here. Hit that. So this would be 0.282. So the probability that x equals 2 equals 0.282. The probability that x is equal to 3. We do the same thing, binomial PDF, NP and 3. So that comes out to be a 0.25. That's a chance you're going to get 3 right. Did I say 3.5? I meant 2.5. Okay, and you could keep doing this the whole time. So say I wanted 6, I do second distribution. I'm going to hit up this time because it's closer. I'm going to put, I'm answering 10 questions. I have a 25% chance, and I'm going to get 6 right. Now obviously these are going to be smaller, because if you're totally guessing, we don't expect to get 6. So this one right here would be okay. The chances go down. It kind of goes up a little bit and then it goes down. This distribution as it is right now would be skewed to the right. It'd be skewed to the right. You can see how this one's really small. We do probability that x. Let me just write this down real quick. See, this is small, and then it peaks around 2. Peaks around 2 or 3, and then it starts going down. So if this was a distribution, it would kind of look like this. So it's skewed to the right. So we couldn't use normal on this. Okay, so that's how you find all of them. Now I'm going to start showing you how to do the CDF. Okay, so let's look. The probability that x is at least 1. Okay, so at least 1, we've done a lot of this. Okay, we've done a lot of this, at least if you've been in my class. If I say at least 1, then I'm interested in 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. But we already know that that's the complement of 1 to 10 would be 0. So I could do 1 minus the probability that x equals 0. Okay, so if I find this, then I can do 1 minus this, and that gives me the rest. Okay, so this would be 1 minus, 0.75, 10. Okay, so we don't need the calculator for this one. We already know how to do that one. But if I ask you any other one, you're going to need the calculator. So what's the probability what's the probability you're going to get at least 5 right? Okay, so I'm interested in this one right here. I'm interested in all these. So you could do all these manually and add them all together, or I could do 1 minus the probability that x is less than, less than, or equal to, 4. Do you see how that works? Okay. And like I said before, we could use the CDF. The CDF will give you a sum from 0 up to a number. A sum from 0 up to a number. So if I want 5 to 10, you could do 1 minus 0 to 4. So this is going to be 1 minus binom CDF. And it works the same way. You put in n, x, or n, p, and x. And if you do CDF, this is going to sum up to x. Okay? So technically, this is finding this. This is finding 1 minus the probability that x equals 0 plus the probability that x equals 1. It just sums them all the way up to the probability that x equals 4. Okay? So this would be 1 minus, and we'll do it here. Say 1 minus second distribution. Go up to binomial CDF. Went a little past it. There's binomial CDF, so it's 1 minus binomial CDF. I has 10 questions. The chance of getting any one right is 0.25. And I want to sum all the way up to 4. If I'm not interested in 4, I'm interested in 5 up, but if I do 1 minus the sum up to 4, it gives it to me. So hit enter. And this is actually the answer. This is the answer. Because I did 1 minus already. So this is going to be 10.25 and 4. And the answer would be about almost an 8% chance. We're on an 8% chance that I get at least 5 right. Okay? Alright, let's try a different one. Try to make this a little smaller. Okay, well, I don't need that anymore. So let's do another one. And you should be kind of getting comfortable. Okay, so what if I said, what's the probability that you get at most, I'll write it out so you could get used. You have to get used to the words at least and at most. At least and at most. What's the probability you get at most 4 correct? No, let's not do 4. I just did 4. What's the probability you get no more than 3 right? At most 3 correct. So which 3 are we interested in? Now I have all these 3, so I could just take this plus this plus this plus these 3. I could add all these, okay? Because it says at most 3. So at most 3 means that x is less than or equal to 3. So x equal to 3 would be the probability that x equals 0 plus the probability that x equals 1 all the way up to the probability that x equals 3. Which this one you don't have to do 1 minus because I'm interested in the left. The CDF will always give you the left. So this is going to be binom CDF 10.25 and 3. And you guys can mess around with these things and show you and prove to yourself that this is it, because you could just add all these 3 and then do what I'm about to do, and you will see that they equal each other. 10 comma 0.25 comma 3. This is going to add 0, 1, 2, and 3. And I get 7.776. So a 77.6% chance of getting at most 3. Okay, so that's how you use your calculator. That's how we use the calculator. So get practice on these problems. write in your notation, here, and answer in the questions. All right, thanks for watching.